In today's video, we're focusing on the evolution of the Earth's atmosphere and how it has changed over billions of years to become what we experience today, with a composition of approximately 80% nitrogen, around 20% oxygen, and the remaining portion made up of trace gases such as carbon dioxide, water vapor, and the noble gases, all of which together constitute less than 1% of the total atmosphere. To understand how this transformation occurred, we need to explore the significant role that volcanic activity played in shaping the early atmosphere, particularly in generating a carbon dioxide-rich environment. We will also look at how the emergence and gradual spread of algae and green plants helped to reduce the levels of carbon dioxide while increasing the concentration of oxygen over geological time. It is important to note right from the start that our understanding of these events is based on scientific theory. Although it is supported by a wide range of evidence gathered from various geological and biological sources, the fact that these events unfolded over approximately 4.6 billion years means that we do not have direct or complete records, and so scientists classify this understanding as a well-supported theory rather than an absolute fact. In the earliest stages of the Earth's history, particularly during the first billion years, the planet was extremely dry and experienced intense volcanic eruptions that released vast quantities of carbon dioxide, water vapor, and nitrogen into the atmosphere, along with smaller amounts of gases such as methane and ammonia. This led to an atmosphere dominated by carbon dioxide, which was quite similar to the current atmospheres observed on Mars and Venus. However, as the Earth gradually cooled, the water vapor in the atmosphere condensed to form liquid water, which collected in low-lying areas to create the first oceans. Once these oceans had formed, they began to absorb carbon dioxide from the atmosphere, allowing it to react and form solid compounds known as carbon precipitates, which eventually settled on the seabed and contributed to the formation of sedimentary layers. A major shift occurred around 2.7 billion years ago with the appearance of algae, and this biological revolution gained momentum over the next billion years as more complex green plants evolved. These organisms are capable of photosynthesis, a process that removes carbon dioxide from the atmosphere and produces oxygen as a byproduct. The continued activity of algae and green plants over billions of years gradually decreased atmospheric carbon dioxide levels while steadily increasing the concentration of oxygen, eventually allowing for the evolution of complex life forms such as animals. However, these plants and algae could only store a limited amount of carbon in their living tissues. When they died, their remains often sank to the ocean floor and became buried by layers of sediment. Over millions of years, this material was compressed and transformed into sedimentary rocks, crude oil, and natural gas, effectively trapping the carbon and preventing it from re-entering the atmosphere. The exact nature of the substance formed depended on both the type of organisms involved and the environmental conditions at the time. For example, crude oil and natural gas were mostly derived from the remains of plankton, which are small and diverse organisms that float in the ocean, whereas coal is a sedimentary rock that was formed from the thick deposits of dead plant material that accumulated over time. Limestone, another sedimentary rock, consists mainly of calcium carbonate and was formed from the skeletal remains of marine organisms, such as corals and shellfish. To summarize everything we have discussed, during the first billion years of Earth's history, widespread volcanic activity released large amounts of carbon dioxide and other gases into the atmosphere. As the planet cooled and water vapor condensed, the resulting oceans helped remove carbon dioxide from the air by absorbing it. Later, the development of photosynthetic organisms like algae and green plants significantly altered the atmosphere by reducing carbon dioxide levels and increasing oxygen levels. This process not only led to a more habitable planet, but also allowed for the formation of fossil fuels and sedimentary rocks as dead organisms became buried and transformed under layers of sediment. Today, as a result of these long-term processes, the Earth's atmosphere is primarily composed of nitrogen and oxygen, with small amounts of other gases. These biological and geological transformations over billions of years explain the modern atmosphere and the presence of natural resources like coal, oil, gas, and limestone in the Earth's crust. That concludes today's explanation, and we hope you found it insightful and informative. See you again next time.